Niels Bohr, a pioneer of quantum physics. Niels Henrik David Bohr, 1885-1962, was a Danish physicist who made foundational contributions to understanding atomic structure and quantum theory, for which he received the Nobel Prize in Physics. In 1922, he is widely regarded as one of the most influential figures in 20th century physics. Early life and education. Niels Bohr was born on October 7, 1885, in Copenhagen, Denmark. His father, Christian Bohr, was a professor of physiology at the University of Copenhagen, and his mother, Ellen Adler Bohr, came from a wealthy Danish Jewish family prominent in banking and parliamentary affairs. Bohr had an older sister, Jenny, and a younger brother, Harald, who became a distinguished mathematician and Olympic footballer. The intellectually stimulating environment of his home, often frequented by academics and philosophers, significantly shaped Bohr's early development. Bohr attended the Gammelholm Latin School, excelling in physics and mathematics. In 1903, he enrolled at the University of Copenhagen, initially studying philosophy and mathematics before shifting his focus to physics. He conducted his first scientific work, an experimental investigation of the surface tension of water using oscillating jets, which earned him a gold medal from the Royal Danish Academy of Sciences and Letters in 1907. He completed his master's degree in physics in 1909 and his PhD in 1911, with a dissertation on the electron theory of metals. While his dissertation was a solid piece of work, it was largely based on classical physics and did not fully account for certain phenomena, an early indication of the limitations of classical theories at the atomic level. The dawn of quantum mechanics in 1911. Bohr traveled to Cambridge, England, intending to work with J.J. Thomson at the Cavendish Laboratory. However, his time there proved somewhat unfruitful. He soon moved to Manchester, joining the laboratory of Ernest Rutherford. This proved to be a pivotal decision. Rutherford's groundbreaking experiments had recently led to the proposal of the nuclear model of the atom, where a small, dense nucleus was orbited by electrons, similar to planets around a sun. However, this classical model had a major flaw. According to classical electromagnetism, orbiting electrons should continuously radiate energy and spiral into the nucleus, making atoms unstable. Bohr recognized this fundamental problem and, inspired by Max Planck's earlier work on quantum theory, began to develop a revolutionary new model of the atom. In 1913, he published his seminal trilogy of papers in the Philosophical Magazine, introducing the Bohr model of the atom. Key postulates of this model included quantized electron orbits. Electrons can only orbit the nucleus in specific, discrete energy levels or stationary states without radiating energy. Energy transitions. Electrons can only gain or lose energy by jumping between these allowed orbits, absorbing or emitting discrete packets of energy called quanta or photons. The energy of the emitted or absorbed photon is equal to the energy difference between the two orbits, delta E equals h nu, where h is Planck's constant and nu is the frequency of the radiation. Angular momentum quantization. The angular momentum of an electron in an orbit is quantized, meaning it can only take on integer multiples of h2. The Bohr model successfully explained the spectral lines of hydrogen, a major triumph, and provided a conceptual framework for understanding atomic structure that went beyond classical physics. While later superseded by more sophisticated quantum mechanical models, the Bohr model was a crucial stepping stone and laid the groundwork for the development of quantum mechanics. Professional career and the Copenhagen interpretation. After his groundbreaking work in England, Bohr returned to Denmark. In 1916, he became a professor of theoretical physics at the University of Copenhagen. In 1921, he founded the Institute for Theoretical Physics, now the Niels Bohr Institute, at the University of Copenhagen, which quickly became a vibrant hub for theoretical physics and attracted many of the brightest minds in the field. Throughout the 1920s, Bohr continued to refine and expand quantum theory. He played a central role in developing the Copenhagen interpretation of quantum mechanics, a philosophical framework for understanding the implications of the new quantum theory, which was largely formulated through discussions with his colleagues and students at his institute, including Werner Heisenberg, Wolfgang Pauli, and Paul Dirac. Key tenets of the Copenhagen interpretation include wave-particle duality. Particles exhibit both wave-like and particle-like properties. Probabilistic nature. Quantum mechanics only predicts the probability of outcomes of measurements, not deterministic results. Complementarity. Certain pairs of physical properties, like position and momentum, or energy and time, cannot both be precisely known simultaneously. The more precisely one property is measured, the less precisely the other can be known. This concept was deeply explored by Bohr, and is one of his most profound contributions to the philosophy of science. Observer, effect, the act of observation or measurement influences the state of the quantum system. The Copenhagen interpretation became the dominant interpretation of quantum mechanics, although it also sparked lively debates and disagreements, most notably with Albert Einstein, who famously declared, "God does not play dice." Bohr, in turn, would often retort, "Einstein, stop telling God what to do." Later work and World War II. Bohr continued to make significant contributions to nuclear physics in the 1930s. In 1936, he proposed the liquid drop model of the atomic nucleus, which proved very successful in explaining nuclear reactions, particularly nuclear fission. With the outbreak of World War II and the Nazi occupation of Denmark, Bohr, whose mother was of Jewish descent, became increasingly concerned for the safety of Jewish scientists. In 1943, he was famously spirited out of Denmark to Sweden in a small fishing boat and then flown to England. From there, he traveled to the United States and became involved in the Manhattan Project at Los Alamos, though he largely served as a consultant and an elder statesman, focusing on the scientific and ethical implications of nuclear weapons. He stressed the importance of international cooperation and open communication about atomic energy to prevent a nuclear arms race. Post-war, years and legacy. After the war, Bohr returned to Copenhagen and continued his work at the Institute, advocating for the peaceful uses of atomic energy and nuclear disarmament. He played a crucial role in establishing CERN, the European Organization for Nuclear Research. Niels Bohr passed away on November 18, 1962, in Copenhagen at the age of 77. Bohr's legacy is immense. His atomic model revolutionized our understanding of matter and paved the way for quantum mechanics. The Copenhagen interpretation provided a profound philosophical framework for interpreting the strange and counterintuitive nature of the quantum world. He fostered a vibrant research environment at his institute, mentoring generations of physicists who went on to make their own significant contributions. Beyond his scientific achievements, Bohr was also known for his deep philosophical insights, his commitment to open discourse, and his humanist values. He remains one of the towering figures in 20th century physics, whose ideas continue to shape our understanding of the universe.